for most of AI's history, we were the loonies. We were the lunatic fringe. As Jeff Hinton famously says, actually, let me put in my own words, the lunatics have now taken over the asylum.
I've never met anyone like it.
He could hack anybody's phone in a matter of minutes. Who is that guy? Who can do that?
Alice is the most interesting man in the world.
He's one of my favorite people on the planet. Inventor.
Wicked smart.
The master of cutting corners.
If you had a dead body in your trunk, who would you call?
He would get arrested immediately in a lineup.
I stood in line to get his autograph.
His mouth can barely keep up to his brain.
I don't actually know what Pablos does.
A hacker magician.
Man of the future. 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 Future.
Like I'm telling you, there's stuff happening right now at who knows, maybe at MIT, maybe at Punk University or some other, that is going to be a big thing. Yeah. And again, getting back to our earlier conversation, the Bay Area cluster is very big.
Yeah.
But it's too homogeneous.
I get it.
Right? So you're gonna go to one of these because there's dozens of them.
Yeah. It feels like there's maybe I don't know if you have a lens on this, but for AI research, a lot of American universities have been gutted, but Switzerland, meaning people are moving into tech companies. But
I wouldn't say they've been gutted, but
okay, all right. I don't know why you aren't working at Google right now. It seems like they're trying to get everybody they can. So, but it looks to me like there's a hot spot in Switzerland and a hot spot in Oxford still. Do you see any others like in AI research
exactly. There is this misperception. Okay. Sorry to call it that.
Okay.
That
I might have it.
Industry has guided academia in AI.
Okay.
This is not true.
Okay, great.
Because only a small fraction of the people go to industry.
Okay.
On any given day. In fact, right now, people have done these, measurements. If you look at the papers in the top conferences, blah, 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 there are more authors from academia than industry. The problem is that, for example, you see a paper that's co-authored by 3 people from a university and 1 from DeepMind. It's like, oh, DeepMind has a new paper. So you gotta filter that out.
Okay.
Right. And there's a lot of people who have a leg in the university and in industry. People say like, XYZ has gone to Google. They're still professors.
Yeah.
And if they're playing their cards right, it's actually good for everybody.
Okay.
Right. Everybody benefits. So there's a lot of people who are halfway between them.
Okay. Got it.
So the perception that somehow now all the AI talent is in industry, there's more and more, and Google at least, they have certainly tried to corner the market. They did at one point.
Yeah.
At this point, it's impossible, right? Yeah. So you're not wrong in that regard, but like, if you look at the reservoir of AI talent in the world right now,
okay,
academia is still the biggest one. And moreover, you could be a 17-year-old kid doing really good AI research and be discovered that way even with no PhD. Sure. But again, going to grad school, finding your people, finding a good advisor to a principal, like, why not do that? Go the hard road, right? There's at least 100. I'm making up this rough number. Like, there's these R1 universities, blah blah, in America, right? There's at least 100 universities in North America. Canada is important, right? Yeah. Actually, great example, right? Okay. Quick parenthesis, and I find this the list, right? Where did the machine learning? Let's look at deep learning, right? If you had asked me this question 15 years ago, right, and I said like NYU has a good group, the University of Montreal has a good group, it's like, what the heck is that? Montreal? Who's in Montreal? There's this guy called Yoshua Benja. Toronto is the top department, which people tend to ignore here, but have very good. Jeff Hinton was there, right? These places, I remember someone at Stanford saying, great guy, but this is outstanding research. I won't name him because there's no need. But he said like, oh, those places are either too far away or too far down, meaning either in Canada or down in the rankings. Well, my friend, where did the deep learning? And moreover, like to go even further back, and then when I was, as I mentioned, like when I was looking for someone to get a PhD in machine learning, right? Like the Stanfords, the MITs, they had nobody.
Yeah.
It's not that they had few people, they had nobody. Because they were like, machine learning back then was their topic.
Yeah, right? They were still doing.
Yeah, another question is like, what are the doing what weird topics right now?
Yeah.
Right? I could name a whole bunch of like weird topics and the places that are doing them. Another, but Schmidt Huber, of course, famously was in Switzerland, and certainly deserves more credit than he got and is very bitter about it. But like, back then there was like, he had the fortune, again, the network effect comes in here. He was in Europe where neural networks were even more ignored and there were even fewer and far between people doing them, right? So there's Cambridge, there's
Well, for you in the in that long history of AI, what were the inflection points that gave you a sense of excitement or optimism? Did you feel it with, probably you got like GPT-2, I got access early on, and I felt something there. Not necessarily unexpected, but I was stoked that it was finally working. What do you remember any moments along the way where you felt like it's really going to work? Or
okay, so good question. There were a few. The first one, and in some ways the most important, was this is 1986 maybe, and I go into a bookstore. This is in Portugal, right? And I see the bookstore almost by chance. They had this was a tiny bookstore, the size of a living room in a little shopping mall. Yeah. They had a tiny section, I don't know why, of foreign language textbooks.
Okay.
I know I had books like they had like electrical engineering and psychology books, but they did, right?
Okay.
And I saw this one book there called Artificial Intelligence.
All right.
It was the first ever AI textbook written by Eleni Rich, published in 1983, just a few years prior. It was like a small format book, like a trade paperback, 400 pages. And I was like, what could this be, right? It seemed almost like an oxymoron, artificial intelligence. That doesn't. So the second time I saw that, I used to swing by that bookstore on my way back from college. And then I bought it.
Okay.
And I read the book.
Yeah.
Right. And when I read the book, I felt two or three key things. One was like, wow, if you can do this, this is going to be amazing, right? You could, I think, I was going to say it would be hard to, but I would be wrong because many people saw it. But me reading that book, I was like, the potential of this is extraordinary, right? So that was the first step. But also, machine learning but at the same time, the state of the art was extraordinarily primitive.
Yeah.
And I'm like, there was some stuff that was okay, the problem solving. They're like, I see what they're doing. This is mildly useful, but this ain't, what these days back then the term didn't exist, AGI, right? Yep. And that was always what I was driving for.
Okay.
Right? That's what I got interested in was the potential of having, not just, my goal has always been intelligence. Like part of what really drove me is like human intelligence is amazing, right? How it evolved is amazing, but it's so damn limited.
Yeah.
Every day I come face to face with how stupid I am.
Yeah.
And if only I could be smarter. So that has always been the goal, right? So I saw that potential there. So that was the first moment. But within that moment, there was another, which was like, they had a tiny little chapter on machine learning.
Okay.
Clearly an unimportant topic.
Yeah.
That was an even more primitive step, but I was like, this is it.
Yeah.
Without learning, AI will not succeed. With learning, AI will go very far. Which at the time, nobody, even in AI, believed in, except for a few people like, Jeff Hinton and others. The first moment, right? Okay. Now, when I got into grad school, right, was in the deepest AI winter.
Yeah,
right. So I had colleagues leaving saying, like, this isn't going in. To abandon grad school saying...
This is the mid-'80s or something.
A friend of mine saying, like, machine learning is, it's impossible to do now. But I had to argue with him about this. And he left and I stayed. He said, machine learning is played out. We've discovered what there is to do. We've asymptoted.
Wow.
And then you have no, well, okay, so here we are now, right? But so the second moment happened while I was in grad school was the beginning of the big data boom.
Yeah. Okay.
There was this, so it's easy for me to gloat, say see, I was right about machine learning. I said one day it'll change the world and now it's happening. But there was something very important that happened, which I should have seen coming but didn't, which was machine learning and therefore AI is where it is today because of the flood of data from the internet. In the beginning was the corporate databases, right? Circa 1995, right?
Yeah.
When it was like, wow, companies have all this data in their databases, right? And then the internet boom began, and there was one thing after another that just brought us more and more data.
Yeah.
But when I saw that, I remember from one year to the next, my classmates who were graduating went from typical PhD, there are no job offers in your field, you find a job doing something, to being flown around by the IBMs and the AT&Ts and like I was, because they wanted, at this point, right? And I could see, wow, and I remember, again, this is hard to imagine now. there was this conference that was just starting called KDD, Knowledge Discovery in Databases. Like, and I just saw like, happened to see like proceedings or Coverly papers, and I asked, one of my perspectives, that there's committee member, chair of the department. So what do you think of this? And it's like, this is weekly, scientifically poor, like something like that. Like, don't bother with that. But I was like, and I initially started publishing papers there because I was like, I know this is in the primitive state, but like the potential here,
Right.
if we can take advantage of this data, this is going to be like fabulous, right? And like, I know, of course, like this is like patently obvious, but at the time, this was people's state of mind, right? And then, I mean, maybe to cut a long story, I'll give you an. Yes, it's true that like when you let's do this in chronological order. In 2005, give or take, Jeff Hinton gave an invited talk at ICHCAI, the big AI conference. I think it was in Edinburgh that year, fittingly for Jeff, because that's where he got his PhD, if I recall correctly. And he gave a talk about this thing that him and a few people were starting to do, on which he called representation learning.
Okay.
Right? And I was like, this is what we need.
Yeah.
There were a lot of hot things in AI at the time, and like I wasn't a big believer in most of them. But I was like, this is what's going to get us there, is representation learning. And started telling people about it, like, 10 years before the, so that was a moment of now you see something that you hadn't, there were things before representation learning that was interesting and so on and so forth, but like, and then they started to have these successes in speech, right? Which people remember, but their first success in speech, I was like, I can see where this is going.
Yeah.
And I couldn't see how it would get there, but like, back in a time like this is the 2000s when hardly anybody believed in neural networks still, right? Yeah. I was like, I started getting into that, right? Yeah. I remember, just to illustrate this point, having like coffee with Yoshua Benjo at the ICML in, I think it was Montreal where he lives, right? And we were joking about, this thing that NIPS should have become NIPS and then KIPS. That was the neural information, blah, blah. Yeah. And then, 10 years later, after the conference, we did a study like we like to do in machine learning, like what are the keywords most predictive of acceptance and rejection? And the keyword most predictive of rejection was neural.
Wow.
Because if you were submitting a paper on neural networks to NIPS in 1990-something, you had no clue what was going on.
Wow.
By then, it was Bayesian information processing systems. Yeah. And then in the 2000s, became kernel, right? Yeah. These were some of the things that were hot. So Yoshua was like trying to get me interested. So are you interested in deep stuff? He said, like, I said, like, because back then, I was doing a little bit of it. You don't have to sell me on that. I'm already sold. And he was like, oh, good, right? Like, so like, how do you think this is all going to play out? Like, and I said to him the following. I alluded to this joke and said, and the next decade, meaning the 2010s, is going to be DIPS.
Wow. Deep
Information Processing Systems. And Yoshua giggled.
Yeah.
This was like so out there,
good,
so funny.
Yeah.
Like not even, he was one of the few true believers. Yeah. Not even he believed in this, but just to say like, at that point I had this thinking that this is going to be the next big thing, right?
Yeah, right.
And then of course, there's the, the Alex ChatGPT moment. All those things are important moments. Yeah. But I would say the following, to jump to the present, right? I couldn't predict that something like ChatGPT would happen when it did.
Okay.
But I would have predicted that something like that would happen.
Yes.
And for a couple of reasons, but the main one is actually very simple, is that language models, even pre-neural networks, it's this jaw-dropping thing that even, back, for the first language models started in the 50s, right? People were trying to do machine translation and stuff like that. And even the simplest n-gram models, right? A trigram model is already shockingly good at synthesizing text. Yeah. You increase the length of, my kid, right, wrote a Markov, these are so-called Markov, right? He wrote, like in Python, a simple little Markov model. Yeah. And mined a bunch of, journals with it. Okay. And gave me a paper, an abstract entitled To Read without saying what he'd done. Okay. And he asked me, it was funny because it was like some, I think, gender studies, blah, 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 right? He's a little mischievous. And he said, like, so what do you think of this? And I said, like, yeah, it's the same old stuff. And then he said, my Markov bot, he called it Markov bot, my Markov bot generated it. And
what year was this?
2000 and, this was, of course, well pre-ChatGPT.
Yeah.
Right?
Impressive.
Google's big revelation was when they had a spell checker that was n-gram based. Right. And this just killed all the rules that Microsoft, you probably know this story, right? Like, why were they able to do this? Because since they have much more data, they could go from trigrams to 4 grams to 5 grams.
Mm-hmm.
And what I've observed, right, is that like, and this I think very important for Amazon, with a bigram and small data, it doesn't look right, right? With a trigram, it kind of starts to look, but you can still tell. But at some point, it's generating whole coherent paragraphs, right? And so immediately you tell yourself, right, like, if this thing ever gets to, mine, it'll generate whole texts that are completely good. This is what's happening now. Now, the barrier, right, was that if you require exponentially more data to increase the n in n-grams. But these people already, actually, most people neglected, but for me, 2000s, this was a key problem. Is like, what you need is you need to be able to build models of language that have the power of an n-gram with large n while not having the data and computational blow-up. And there's a few ways to do this, but the key thing that transformers did was exactly this. A transformer is really like an n-gram model that by gradient descent picks out which of those words to pick to and doesn't have the exponential blow-up. Combine that with today's internet scale of data, and we are where we are. So in a way, that the ChatGPT breakthrough was not surprising. Now, as I said, I could not have predicted that it would happen then. And it's one thing to think that this is going to happen. It's another, and you can sort of like forecast some of the things, and I did that in the last chapter of the Master Problem, but like the whole way this is all playing out today, is way beyond.
Yeah, I think it's there for at least for people who were deeply into what was possible with computers, and I had some early experiences trying to work on AI systems, not research, but in trying to build things with those, even just early expert systems and stuff in the late 90s. It's not hard for me to believe that this trek. I think I always believed this trek. I think the miracle of ChatGPT really was just that they got a massive amount of compute. They had the conviction to get that many resources aimed at that. At one algorithm, basically.
To be fair, there's something to give OpenAI their due. Google was already doing this.
Right.
The thing that OpenAI did, which was, I followed this all at the time. I was like, this is definitely a great thing to do. I didn't see what would follow. Was they started the post-training. Right?
Okay.
Because a large language model by itself, right, trained to predict the next word and therefore able to generate it, it will generate plausible text, but again, that's really where the harnesses began. Right? It's like, it doesn't quite do what you want. And
training is a harness in some sense.
So the thing is like, now but again, context of the NLP research at the time, this was a very natural thing to do. Because it was like, they had all the different test beds, and you want to do well on all of them. And basically what they were doing, which was just a natural step, as often is the case beyond what was like, we were pre-trained again. Jeff Hinton was talking about pre-training back in that talk in 2000 and something for different reasons, is often the case. But like, you pre-train on this very large corpus, you take advantage of it, and then you can fine-tune it to these different applications, and then you do very well on them using the small data that is available for them, right? And then what ChatGPT, as you probably know, was just a way to gather data from people. That's why it has a clunky name and everything. And they bet around how many people use it, and the highest bet was, I think, maybe Greg Box said 100,000, right? But what they do is that at that point, they actually, by again piling on another, again, machine learning, not a handwritten harness. It's like, you're just going to do this thing like, I'll give you 2 answers and let you rank which is the best one. Which is exactly what Google's search engine is based on, right? So this is already a technology that we know is fantastically powerful. So they just combine 2 things that on their own are known to be fantastically powerful. The large language say, and this sort of like A/B ranking type of learning. And then they kind of turned it into reinforcement learning, which was a huge waste. But that itself is ironic, but it's a different story. But adding that part is what really turned it into something that people could find useful to do all that they're doing today.
If you had to, do you feel a sense of? I sort of feel a sense of annoyance that deep learning has just sucked all the air out of the atmosphere, and that everybody's just trying to milk deep learning for everything you can get out of it, and by extension, the other architectural things go with it. Whereas it feels like there's probably real potential in radically different approaches to AI that are being neglected. Do you feel that way, or do you feel like we should be? I know you can see obvious cases like Jan LeCun saying, "I want to do world models," because he's seeing the limits of what we can do with LMs. That's probably the poster child. But some version of that is probably true. And there's, even for language, we know this is a wildly inefficient way to do language. So we know your brain has some other better way we haven't found yet. So we know that it can do it, but it should be better, and we're making it somewhat better. But should we be searching for the other ways of making AI go?
I would say I'm frustrated more than annoyed, and honestly disappointed with my colleagues, particularly the academic ones, because our job is to not. The point of academia is to not fall into those things. In industry, I understand you have a shorter time horizon. They tell you can do all this research, but like everybody knows, that only lasts so long.
Spam filter,
right? Right. So you should be aware of that, right? But so you're exactly right. Getting a PhDs, knowing more and more about less and less until we know everything about nothing. AI, what we're doing is more and more research about less and less until we're going to be doing infinite research about nothing, right? So that is very much happening, and it really frustrates me that all these resources, 99% of them are wasted. This is all stuff that, when the next generation happens, wherever it might come from, is all going to be a complete waste of time. I understand industry doing it for the short-term gain and blah, 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 but in academia, there is no excuse for doing that.
Okay.
If you're whining to me that you can't compete with the NLP that they're doing in industry, then you shouldn't be doing that NLP. You should be doing some other NLP. Because as you say, AI is such a hard and vast problem, right? My biggest criticisms of the Dario Modas of this world, you have just no idea how much bigger than your brain AI is, right? There's this famous saying, which you can see in the New Light today, which is that for most of AI's history, we were the loonies. We were the lunatic fringe. As Jeff Hinton famously says, actually, let me put in my own words, the lunatics have not taken over the asylum, right? But we were like, these people are crazy. And one of my arguments was I forget, who says way back, I think in the 60s, if we were so simple that we could understand ourselves, we would be so stupid that we couldn't, right? Now, there's a flaw in this argument, but there's also a truth, which is, let me put it this way. There's a famous school of thought in AI, like Marvin Minsky wrote a whole book about this, The Society of Mind, that is literally intelligence is one damn thing after another. Stop trying to find the solution because there isn't one. You just have to do one thing after another. By that standard, the current AI research is failing because they're engineering, blah, blah. I actually do not believe in that. I do not believe in that because of machine learning. Because back when I started getting interested in AI, in my early 20s, I started making a list of the capabilities we needed to have. And that list just kept growing forever, right? Which was, and the thing is, but with machine learning, you can actually have an underlying set of capabilities that then generates those in contact with data. And that underlying set can be much, much smaller. And we're seeing that now. Look at all the things that Transformer can do, right? So we need to figure that out, right? So I would also say that the brain is probably more complex than it needs to be in many ways, but I really don't think we have found, I mean, if you look at neuroscience and computational science, which I like to try to keep up with as much as possible, right? It's impossible to not look at the brain and not think there's something that this is implementing. And it ain't backprop. Right? So what the heck is it? Right? And there's a good chance Jeff Hawkins famously wrote the bestseller about this canal intelligence that actually inspired Andrew Ng to go into deep learning and whatnot, among other things, right? A little known fact, which is there's this algorithm that the brain is running. We just need to rediscover it. This was also part of the motivation for my title, The Master Algorithm, right? And whether AI is the Minsky version of one damn thing after another, or there's a few really key things, right? The percentage of the community that's looking for this right now keeps ever shrinking.
Smaller, right?
Now, to paint a positive note, right? Very positive note. This is a recent development in just the last really year. There have been all these neolabs. Jan is involved in actually a couple of them, but he has his, AMI one, and there's a whole bunch of things, right? The world models, blah, blah. So, and we could look at the pros and cons of each. But what is really positive for me is that there are a lot of people deliberately trying to do this. And the VCs actually at this point, because they look at the history of OpenAI and help you say, if I bet in one of these labs, chances I won't go anywhere, but it could really be the next big thing, right? So there's actually people doing this, researchers, not enough in my view, and even funding for them. And again, but unfortunately, the model that they have are I'm going to be the pitch that these people are making to the VCs, some of them are my friends, right? So this is not meant as a criticism, but it's they're saying to, you know, believe me, I'm a really good AI researcher. Here are my credentials, right? I have a track record, and now I'm going to discover the next big thing in AI. Not only do I have no business plan, I have no idea what the next big thing is going to be apart from videos. Give me $1 billion, please.
Yeah, exactly. That's what it seems like they're doing.
And it might even pay off.
$1 billion after you make the discovery.
No, but here's the thing, right? In the aggregate, that might be the case, but the new labs have a huge flaw, is that they're all in stealth mode. They don't talk with each other. So as a research system, it's bigger. It's better than a few big labs only, but it doesn't beat the open academic system.
Probably right. Yeah.